Welcome to Tech Uncovered. Discover, learn, apply. Brought to you by Physical Sciences Consultorium. In this episode, we explore LIDAR technology, a groundbreaking tool that uses light to map the world with remarkable precision. From self-driving cars to archaeological discoveries, LIDAR is revolutionizing how we see and interact with our environment. Let's dive in. LIDAR, or light detection and ranging, is a remote sensing technology that measures distances by illuminating a target with laser light and analyzing the reflected signals. It works similarly to radar, but instead of using radio waves, it relies on pulses of laser light. By rapidly sending out thousands or even millions of laser pulses per second and measuring the time it takes for the light to return, LIDAR systems create highly accurate, three-dimensional maps of the surrounding environment. This technology is widely used in various industries, offering unprecedented precision and efficiency. LIDAR systems consist of three main components: a laser emitter, which sends out the light pulses, a sensor or detector, which captures the reflected light, and a GPS and IMU, inertial measurement unit, which help determine the exact position and orientation of the system. Together, these components allow LIDAR to create detailed 3D models with centimeter-level accuracy. Unlike traditional imaging methods, LIDAR can penetrate through obstacles like vegetation, making it extremely useful for applications in forestry, archaeology, and environmental mapping. So, where is LIDAR technology making the biggest impact? One of its most well-known applications is in autonomous vehicles. Self-driving cars rely on LIDAR sensors to detect obstacles, pedestrians, and road markings in real time, ensuring safe navigation. By continuously scanning the surroundings, LIDAR helps vehicles react to their environment with incredible accuracy. Another key application is in geospatial mapping and surveying. LIDAR is widely used to create detailed topographical maps, monitor coastal erosion, and even study the effects of climate change. Its ability to generate 3D models of landscapes makes it indispensable in construction, urban planning, and environmental monitoring. LIDAR has also played a transformative role in archaeology. Researchers have used it to uncover lost cities, ancient structures, and hidden landscapes buried beneath dense forests. Unlike traditional excavation methods, LIDAR allows archaeologists to map large areas without disturbing the ground, providing valuable insights into past civilizations. In meteorology, LIDAR helps scientists measure atmospheric conditions, track pollution levels, and even monitor wind patterns for weather prediction. It is also used in forestry and agriculture, where it assists in assessing tree density, crop health, and land management strategies, helping optimize resource usage. Despite its many advantages, LIDAR does face some challenges. One limitation is its high cost. LIDAR systems, especially high-precision ones, can be expensive, making them less accessible for smaller applications. Another challenge is performance in adverse weather conditions. Since LIDAR relies on laser light, heavy rain, fog, or dust can interfere with its accuracy. Additionally, data processing can be complex. The massive amount of data generated by LIDAR sensors requires sophisticated algorithms and computing power to analyze and interpret. Looking ahead, advancements in solid-state LIDAR, AI-powered data processing, and miniaturization are making this technology more affordable and accessible. Emerging applications in smart cities, drone-based delivery systems, and even space exploration are pushing the boundaries of what LIDAR can achieve. With ongoing research and technological innovations, LIDAR is set to become even more powerful and widespread in the years to come. LIDAR is truly changing the way we perceive and interact with the world around us. From enabling self-driving cars to uncovering hidden historical treasures, its applications are vast and ever-expanding. As we continue to refine this technology, its impact on science, industry, and everyday life will only grow. Thank you for watching this episode of Tech Uncovered. Discover, learn, apply. Stay tuned for more explorations into groundbreaking technologies. For collaboration inquiries, reach out to us at psconsultorium@gmail.com. Don't forget to like, share, and subscribe for more exciting content from Physical Sciences Consultorium. Until next time, keep discovering, learning, and applying.